Hello everyone, welcome to my youth programming club. Today we will be solving another daily Leetcode challenge, and the name of challenge is find in mountain array. So it is mentioned that it is an interactive problem. You can recall an array. You can recall that array is a mountain array if and only if the following condition satisfies. So there should be at least 3 elements in the array, and basically there should be a peak element in the array. There should be an element I such that before that particular element, uh, the till that particular element, the array is in increasing order. So from 0 to I, you can see that the array is in increasing order, and after that the array is in decreasing order. So two adjacent elements cannot be equal. Here the equality is not mentioned here. Okay, so something like this should be there. Till a particular index, let's say I, the array should be in increasing order, and after that it should be in decreasing order. So given a mountain array, return the minimum index such that mountain array dot get index equal to target. If such an index does not exist, you should return -1. Okay. So you cannot access the mountain array directly. You may only access the mountain array interface. So mountain array interface will be containing two methods. One will be mountain array dot get returns the element at index k. Okay. And another will be mountain array dot length returns the length of the mountain array. So your submissions making more than 100 calls to this particular function mountain array dot get will be just wrong answer. Also, it is mentioned that any solutions that attempt to circumvent the judge will be resulting in disqualification. Let's have a look at the constraints. According that, we will be forming our solution. So the length of mountain array is ranging from 3 to 10 raised to power 4 elements, and the target is between 0 to 10 raised to power 9. And the mountain array dot get index will range from the same range in which the target is 0 to 10 raised to power 9. Okay, so we will try to solve this particular problem in the most optimal way possible. So without further delay, let's see how we will be solving this problem. So to solve this particular problem, what we will do is, since there is a limit on get function, so we should try to write most optimal answer. That we can. So if we have to search in this particular mountain array, then instead of linear search, linear search will require you at max order of, let's say, n calls, where n can be the size of your mountain array. N will be your size of mountain array. Okay. So to reduce the number of calls to get function, you should use binary search. Binary search. That will require you at most order of log n calls. It will be little more than that, but the order remains the same. So it will reduce your number of calls. So this is the most optimal solution I can think of as of now, which will be there. But you may ask, the array that we will be given will not be in sorted form. So it can be something like this, 3, 4, 5, and then let's say it is 4, 3, 1. So as you can see, the whole array is not sorted. But I would say is that this portion of array and this portion of array, these two are sorted. The whole array is not sorted, I know, but these two are sorted. It is sorted in decreasing order. And this one is sorted in increasing order. So binary search can be easily applied here. We just have to find the peak element. For peak element also, to reduce the number of calls. Number of calls to get function, we can use binary search. So in total, how many binary search will be used? 1, then 2, and then 3. So 3 binary searches will give us the index of the target. Or I think the smallest index is mentioned. Given a mountain array, you have to return the minimum index. Yeah, minimum index you should return. Minimum index. Okay. So let's try to implement the solution. Those of you who are not familiar with binary search, I will be providing a link or an article describing what binary search is. can explore that link and you will be able to understand the problem in a much clearer way. So this particular article will be provided to you. Link of this article. Okay, here it's mentioned in depth how binary search works and its implementations in various languages. So let's move back to the problem. Let's try to implement it. First of all, we will find the peak element of the mountain array. Finding the peak element of array. We are using binary search on the search space comprising of indices of the mountain array. Okay, and one thing I would also like to mention is, yeah, I think it's fine. Let's proceed. Uh, let's declare the left and the right ranges of binary search. First of all, let's capture the size of the mountain array. Let's shorten this name. MARR will be, I think, fine. Okay, so the limit is only on the get function. Okay, not on the length function, but we are using it only once. Okay, and then last index. From 0th index to last index we will be searching. And this is just a standard binary search with some little tweaks. Here it is to be noted that I am not uh, allowing left to be equal to right, since I will require at least two elements to make comparisons. What will be the comparisons? I will tell you along the way. So we will find the mid index, which will be nothing but left plus right minus left by 2. This left plus right minus left by 2 is nothing but, if you simplify it, left plus right whole divided by 2. This is just to avoid integer overflow. Okay. And yeah, so we will be comparing the mid element and the element at the mid index. Mid index and one element next to it. If let's say the element at mid index MARR dot get mid index is lesser than arr.get mid index plus 1. So the next element, very next element to the mid index. Then what we will do is left of your range will be shifted to mid index plus 1. So why we are shifting the left of your range to mid index plus 1? So consider this case. If let's say you are here, this is your mid index and the element very next to it is greater than this. So to find the peak element, you should be moving in this direction. So to move in this direction, your left of your range will be shifted to your mid index plus 1. Okay, that's why we are doing so. So, and also let's define a variable peak index. Basically, initially it will be having a value of, let's say, last element. Okay, you can give it any value, it will change. So peak index will also be this mid index plus 1, since we are uh, required to find the integer of the peak index. So this particular binary search will be to find the index of peak element in mountain array. Okay, and yeah, let's proceed further. And if that's not the case, and if let's say you are in this particular region, okay, so if that's not the case and your mid element or mid index element is two elements cannot be equal, so this will be that your mid index element is greater than this particular element, which is nothing but mid index plus 1. Okay, the you are in the decreasing, you are in the on the descent, not on the ascent part, so you are in the decreasing part. Then you will what you will do is uh, else if array of mid index marr or mountain array dot get mid index, or we can avoid the call of get here, we can just use else only, since it is well understood that you are trying to implement a condition something like this. So just to avoid this call, we are using else. Okay, this get in, what call I am talking about, the a call of get function. Okay, and since we are not we do not want to lose mid index, It can be our peak index. Why it can be our peak index? Because this particular condition that we are checking also satisfies for the peak index. This element will be greater than the very much next element to it. So array of I will be greater than array of I plus 1, because after the peak element, the array will be in a decreasing trend. Okay, so that's why we are doing so. And so we will just store your right will be mid index, not plus 1, only mid index. Okay, and then what you will do is we will try to find the peak element index in right part first. You can choose the left part first also, that will not matter. By using binary search, in right part. Right part will be comprising of which will consist of or comprising of indices from peak index size minus 1. Okay, so let's redefine the values of left and right. So your left will be now peak index and right will be having value of size minus 1. Okay, and in this particular part we are not interested in comparing two adjacent values, so we will be using the condition left equal to right. Okay, and we will be using a standard binary search implementation without any tweaks. So let's solve the problem. First we will be finding our mid index, which will be nothing but left plus right minus left by 2. If you are still not able to understand why I'm using this condition, I think it should be mentioned in this article why we use this particular condition. Mid is equal to, as you can see, this particular way of finding the mid is also used here. So I think it should be mentioned in the article. If it's not there, please ask in the comment section. I will be more than happy to answer with further elaboration. So we are done finding the mid index, and then we will search for the target. Yeah, target. If your, let's say, mid index value is lesser than target value, then what you will do is, first of all, let's check if uh, mid index is having the value of target, or I think it's fine. We will check it at last. So left will be shifted to mid index plus 1. Okay, and then if that's not the case, and if your, let's say, value at mid index happens to be greater than the target, then you will shift your right to. Basically, in these two cases, you are just reducing your search space. Okay, so mid index minus 1 it will be, and else if you have hit the target, if you hit the target, then you will return true, or not return true, you will be returning the mid index. So this will be the index of your target. Okay, and similarly you will do binary search to find the target in left hand side if it's not there in the right hand side. Okay, we can just copy this binary search and we try to find the peak element in the left side of peak element by using binary search in left part, which comprise of the indices from 0 to peak index. Okay, so these values will be changing. Instead of peak index, left will be at your 0th index and right will be at your peak index. I think rest all should remain pretty much the same. I think we have done a mistake here. Since we were doing binary search in the right part, we should have considered that it is in decreasing order, so we should reverse the signs. Only then it will give you correct answer. So I think you understood that why we are reversing the signs, because this binary search we were considering for the increasing array. So to accommodate the decreasing array, we are reversing the signs. This one is correct for the increasing array. Okay. So your right will be pointing to the peak index. And then yeah, that's pretty much it, I think. At last, you can return any value. Or if it's mentioned that if answer does not exceed, you should return a particular value. Let's check. Yeah, it's mentioned that you should return -1 if the target is not existing. So we will do as the problem asks. So we will return -1. I think there is one brace extra in the implementation that I have used. Yeah, we have implemented these two binary searches inside the first binary search. Anyhow, we will rectify that by moving it out of these two binary searches will be moved out of the first one. So this is your first binary search and these will be the other two binary searches. So let's try to submit for the sample test cases. It's giving some compilation error. Okay, here I by mistake took it n-1, which should be size -1. So for one test case, it's giving incorrect result. I think I found out the mistake. Here we are getting wrong answer because we are finding the occurrence of 3 here. This particular occurrence we are finding. But we should be giving this answer. So we should be checking in the left part first instead of checking the right part first. So order really matters here. I thought the order will not matter, but the order matters. So left side will be checked first. Left side of peak element first because we have to return minimum index of occurrence of target value. Okay, so let's try to submit again for sample test cases. As you can see, it's getting accepted now. So the mistake that we did was finding for the right part first. So you should be finding checking the target in left part first in order to give the minimum index possible of target occurrence. So target can be existing here also and it can exist here also. As you can see in this particular example or sample test case, 3 is existing here and 3 is also existing here. So this is the your peak element. So it is existing on the left part and the right part. If you do binary search on right part first, then you will give the higher index. So to avoid that case, we will do binary search in left part first. Let's try to submit it for the final evaluation. As you can see, the solution is getting accepted. So the code will be available in C++ and Java both. Uh, and I will also try to make it available for Python 3. So thank you for watching. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. Thanks.